Aiken! What's up, bro? How you doing, my friend? Aiken. The man, the myth, the legend himself. It's Aiken. How you doing, my man? Always first. Number one in my stream and number one in my heart, Aiken. You doing good today, my man? Hopefully you had a nice full day. It's probably pretty late where you're at. Ugh. It's super cold in my house today. I don't know why. Like, the heat's like, it's not even cold enough to turn on the heat yet. How we doing? How we doing? How we doing? Doing good? Yeah. How's everybody today? Hey, Eugene. You did rough on that test. It's not... Well, you still got time to improve your score if you wanted to give it another shot after class here today, Eugene. Remember that the due date for the test here isn't until 11:59 tonight. So, if you're not happy with that score, you can always try again and see if you can work within the time limit before time is up. I would like you to get a better score. Yeah, just with different numbers. That's why I give you 5 retries. So if you learn enough from the first go round, the second go round ain't so bad. I gave you 5 retries, so yeah, you get 5 chances. Like I said, first go round don't go so hot. You can always try again until you get the best score possible. I mentioned that when I talked about the rules of the test. It's even written on, it was on the email there that I sent out. Let's go this way, Here we go. Wait for people to come on trickling in. Well, that's why I say, you want to do stuff at the last minute. It usually doesn't go so hot, Eugene. I'm just going to give you fair warning. That's why I gave you plenty of time. You know, back up the words with action. You got to make sure you don't cram everything at the last second. It doesn't work out so well. Not with this class, I'm telling you right now. Issa, good evening to you. Good evening. How we doing? Like I'll be perfectly honest with you, Eugene. I just want to see you succeed, and I just don't want you to paint yourself in a corner that you didn't need to in the first place. That's all. I just want to see your success. So I'm pretty good. It's been a pretty fantastic day here so far. Hopefully, we'll be working out more on the positive end for tomorrow. Tomorrow is the start of the weekend, so there you go. Hopefully, you got some plans there for the weekend. Yeah, I had one question on the homework where I put the right answer and said it was still wrong. Yeah, sometimes my math lab will ask for the answer to be put in a certain way. So it'll tell you that the answer's right, but it says, well, your formatting is wrong. If you took a picture of it, you can put it on Discord. It may have something to do with the formatting of the question. So if you want to post it on the general chat there for Discord, I can direct you in that general direction. Alright, hopefully we'll get a few more people coming in. Okay. Alright. 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 Good stuff, ladies and gentlemen. Alright. Check the Discord. Thank you, Wait. Appreciate the follow. Alright. Okay. So, I think we're ready to go ahead and get going here with some new material. So let's go ahead and get started here. Let's do some intros and let's get moving with you stuff. Question mark. All right. Let's do it. Okay, let's get started with today. Welcome back to Thursday, end of the week time today. So today, ladies and gentlemen, we're going to be continuing to move forward here in Chapter 5. We're going to be doing Section 5.4 here today. Okay, so just moving on here, just one section at a time. We're getting through it, no problem. We're doing a lot of examples here today. So let's get started, yeah? All right, so let's go to the big board, and let's see exactly that up there. Let's see exactly what we're working with. All right. Okay, so let's talk about what we're going to be discussing here in this particular section. In this particular section, we're going to be talking about a particular type of probability, which is talking about conditional probability. So that's what we're going to be talking about today here. We're also going to be computing probabilities using what's called the general multiplication rule. You'll see how both these things kind of intertwine together when we go ahead and do some examples here. I'm going to actually physically see how we can do this and basically be able to visualize how we can calculate these type of probabilities out using the multiplication rule or the general rule here that we'll see a little bit later on. We'll also be talking about other types of probabilities, like probabilities that'll be dependent, such as replacement and without replacement as well. So we've been kind of focusing on here so far, kind of adding. We did the addition of probability A or B back a couple sections ago. Last class, we talked about the multiplication rule. We said, okay, the probability A and B if they're both independent events. So today, we're now working away from independent events. We're now going to say, what happens if one event is dependent on the other? What happens in that particular circumstance? Well, the first case that we can fall underneath is a conditional probability. Let's talk about what a conditional probability is here first and foremost. So let's look at question 3. What is a conditional probability and what is its notation? So the formal definition here for a conditional probability is the probability of one event B given that an event A has occurred. So basically, here's what we're talking about here in this section. We're going to be given a particular condition, all right? And we'll call that event A, okay, for example. That's the condition that's set. What is the probability that some other event happens, call that event B, with that condition that we are already given in that being event A? So essentially we're finding out the probability within already an existing circumstance. Now, one of the big keys that I put down here is to how you should read this notation here. And it is going to matter quite a bit here in this section. Let's talk about that, how that's going to work. First of all, look at the notation here. We have P and we have B with this line in the middle and A. Now the way we read this here, we read from left to right, we say the probability of B given A. Okay, so A is the given condition, and we're trying to find out what the probability of this event B is going to be at the end of the day. Now, why is this important here? Well, The reason why it's important to read the probability from left to right is because of the fact that order in this circumstance is definitely going to matter. What letter comes first and what letter comes second actually makes a significant difference in the overall probability of of pretty much every scenario. So we're not going to get the case where, hey, I'm going to get the probability of B given A and the probability of A given B being the same. That's actually not true. Now, how do we actually compute these conditional probabilities? Let's look at question 4 here. All right. So the probability of B given A, as you can see here, is the probability of A and B divided by the probability of A, or the number of A and B divided by the number A. Now, I put those here in letters and, of course, in words as well, so you know what each of those represent. And as I said before, you cannot make the assumption that both of these probabilities will be the same. Actually, most of the time, actually 99.9% of the time, they won't. All right, they are two separate probabilities at the end of the day. And like I said before, order definitely matters. Okay, so that's all well and good. Fine. All right. Now, this is kind of the abstract ballpark looking way to kind of look at these types of probabilities. All right, that's fair. But we need to look at practical examples to actually see how we can apply this probability from an easier perspective, because I don't disagree. You look at this, you're like, this looks pretty confusing. I said, yeah, I ain't gonna lie, it kind of does. So how do I actually do these conditional probabilities without, putting in too much brain power to actually figure it out? Well, let's go ahead and take a look at some practical examples, and we'll see how it works. All right. I'm going to take the book out for this one again. And so for this one here, let's look at, I'm going to go ahead and on this side. Do not have the tool. I guess I don't. Maybe take out the paint tool for this. Okay. All right. So let's take a good look here at number 17. Okay, now this should be a table that we should be a little familiar with. We saw this table a little while ago in another capacity. But anyway, let's go ahead and read this problem off here together, and let's see exactly what we're working with. Okay, so number 17. In a recent Harris poll, a random sample of adult Americans 18 years and older was asked, when you see an ad emphasizing that a product is made in America, are you more likely to buy it, less likely to buy it, or neither more nor less likely to buy it? Results of the survey by age group are presented in the following contingency table. Okay? So, let's take a look here. We have the table here. We have more, less, or neither, and we have the respective age groups that we can see here. Fair enough. Now, the questions for this problem here is going to be on the next page, but I'm going to go ahead and write those out anyway. So we'll go ahead and do these together. Let's look at letter A. We'll go ahead and read it off at the very least. Letter A. What is the probability that a randomly selected individual is 35 to 44 years in age, given that the individual is more likely to buy a product emphasized as made in America? So, let's put this here carefully. Want to find the probability of 35 to 44, given that they are more likely to buy. This is a different class here, Beast. But I'm doing the same material as what I did before. It's just that those are two different classes. Hey, Gemma. How we doing? Gemma G. E-O-G. Holy smokes. Sheesh. Even I'm surprised. I know. Let's go. All right. So we're trying to find the probability of 35 to 44 given that they're going to be more likely. All right. So let's break this down into two parts, okay? So we're going to break this down into two parts here. We're going to break this down into two parts. So the first part here is when I look at the bottom. Remember, let's look at the condition here first. You're given, you have the probability of 35 to 44 given that you have more likely. Like I said, Beast, you can call me whatever you want. I don't mind. Uncle Chibs. Alright. You want to find the number of more. That's what we're going to say here. The number of more. Alright, so let's look at it this way here. That's not very nice. I know my Spanish. At least I know that Spanish. Alright, so we have the number of more, and then on top here we're going to have the number of... number of 35 to 44 and more. So on the level, this is what it essentially looks like here. Let's move this over here. You're gonna be an auntie? Ooh, congratulations. You have a sister or a brother who's gonna be having a child, their family. Or is it a cousin? Could be a cousin too. I consider that to count. Alright. So, let's take a good look here. Your sister's having a baby. Well, congratulations to your sister, Gemma. That's wonderful news. Do you know if it's a boy or a girl? I just have to ask. How many people are in the more category? So let's go with that here. How many people are in the more category according to the table to our left? How many people are in the more category according to this little table here to our left for number 17? Go ahead and type your answer out there in the chat. How many people are in the more likely category here? Just kind of follow my thought process here. All right, 1329. Okay. Okay. Now follow my thought process here. Follow my thought process here. We're talking about 35 and more here. That's what we have on the top. Now, only think of it this way. You guys have just said that the number of people in the more category is 1329 total. Out of those 1329, how many of them are 35 to 44? So out of the 1329, how many of them are 35 to 44? Oh, that's so nice, Skitty. Okay. Okay. Good, good, good. All right. So that is going to be your probability here. 1329 up top and 1329 on the bottom. And out of those 1329, 329 were going to be there. All right. Now go ahead and divide that out for me. 329 divided by 1329. And what do we get? What's our decimal here? Again, 4 decimal places, what I'm looking for. Daft, thank you for the follow. Appreciate that. No, you're fine, Gemma. You're fine. Sorry, I'm just trying to get through this example, that's all. The gender reveal is going to be in November. I gotta know, what's your money on, Gemma? You think boy or girl? 0.2476. Good. Nice. That is correct. All right. Okay, so 0.2476 is the correct answer here. Good. All right, any questions about part A? I guess I'll just apologize to Jim. I just had to get through this. All right. You're hoping it's a girl, but I'll be happy with either. Very good. Very good. Are they gonna name the girl Gemma? You gonna name the girl Gemma? That's because that's what should happen. You should have like a niece named Gemma, and then you'll be Gemma and be like the Gemma generation of Gemmas. You know, that's the double G's, generation of Gemmas. That's what I'll put and put. GG. All right, let's look at letter B. All right, letter B. What's the probability that a randomly selected individual is more likely to buy a product made in America given that they're 35 to 44? Okay, so in this case here, we now are reversing this around. We're finding the probability of more given that we're in between 35 to 44. Okay? Alrighty. Now let's follow this along here. Okay, so let's ask this question here. How many people are according to our table here, are going to be between the ages of 35 to 44? How many people? Because that's the number we're going to put on the bottom. That's our given condition here. I'm just going to be happy to be an aunt. I think you will be a fantastic aunt, Gemma. I think you'll be a fantastic aunt. You are very loving, you are very caring, and I'm sure you're going to spoil him or her senseless. And I think that love will certainly show every single day. How many people here? How many people between 35 to 44 according to our table here? 536. Okay, good. So we have 536. Well, out of those 536, how many of them are in the more category? That's right. I agree. Yeah, I did. Skinny's like saying I did the same. Don't buy 0 to 3 month clothes; they grow out of them. Yeah, that's true. That's true. How many of them are in the more category? 329. That's correct. Good. So what's our probability here in this case? What's 329 divided by 536? 329 divided by 536. Anybody got a decimal for me here? I need a decimal. I mean, I don't know. You guys got to tell me. Go 0.6138. Okay. Good. All right. All right, very good, very good. So if you take a look here, both of these probabilities are different, okay? Even if we reversed it around, we said the probability of 35 to 44 given more was 0.2476, but the probability of more given 35 to 44, a completely separate and different probability. So you do not make the assumption that they're the same. Always work it as individual problems at the end of the day. Okay, very good. All right, so any questions so far about those two examples? We're going to come up with a couple more examples here, so a few more definitely. Okay, before we move forward here, I totally forgot to mention this, but I think Julie, you contacted me. It was brought to my attention that there was a problem on the test that had stuff to do with standard deviation of a group data set on the test. And I believe it also it had like group data mean and stuff like that. I just want to bring it to your attention since that was brought to my attention and that was something that we actually did not cover here in this class, as I got confused. I covered it in my first class for 120, but I didn't cover it in this class here. Essentially, I just removed the question from the test and you'll be receiving credit for that question for your exam. So if my math lab doesn't automatically change the percentage, I'll just change the percentage in the gradebook once that's all set and ready to go after today's due date. So again, I did remove one question there from the test because again, well, I'm going to hold steadfast to what I said before. If there's things that we didn't cover and I accidentally put it on a test, then yes, it will get removed, and yes, you will get the proper adjustments in your favor. So I will. I just wanted to point that out there, since it was brought to my attention. All right. Oh, so if you see a slight grade change because of maybe from what you did before to now, then that's because I just took out a question altogether. So instead of 30 questions, there's 29, actually. So, all right. All right, so just wanted to point that out there. All right, let's move forward then. Okay, let's do the next one. All right, so let's do letter C. All right, so letter C, this is the one I'm going to make up this question here, just to let you know. I'm going to make up this question. So let's say the probability, so according to this table here, the probability of, let's say, 55 plus, given that they're neither, whatever. Okay, so can anybody tell me here, how could I find this probability? The probability of 55 plus given neither. Go ahead and post your answers in the chat there. Probability of 55 plus given neither. What do you guys think? Probability of 55 plus given neither. Okay. Post your fraction there, Angie. How'd you get that? 0.1542. Tell me how you got that. What did you divide in order to get that? Okay. You took 118 over 765. All right. Anybody else? Go ahead and post what you think there in the chat. again, post the fraction there as well, Chioma. Just post the fraction, that's fine. We will find the decimal equivalent. But post your fractions in there. Now I'm questioning. Don't worry about that. We'll see if you're right or not. The suspense. This wasn't supposed to be a dramatic stream. I'm sorry. In a world of devastation, to unite all peoples within our nation. Oh man. All right. Anybody else got? All right. So Julie's got it. Chioma got one. All right. Anybody else? Want to put down what they think? All right. Well, let's take a look here and see what we have here. So we take a look here. We have our given condition here is neither. So again, in this case, how many people are in the neither category? Well, that is correct. 765 people are in the neither category. How many out of those 765 are 55 plus? Well, that happens to be 118. That indeed will indeed get you the 0.1542. That is exactly correct here for this particular problem. Good. All right. So far, so good. Yes. IMDb 5 stars. All right. Let's try another one. How about the probability of less likely given 18 to 34? Okay, so let's try this one here. The probability of less likely given 18 to 34. Probability of less likely given 18 to 34. What do you guys think? Probability of less likely given 18 to 34. Go ahead and post your fractions there in the chat. And we'll see if we're right. Went 2 over 66, okay. Yeah, that's that. Go. Got that. Okay. 22 over 66. Probability of less likely given 18 to 34. All right. Any other guesses? Any other guesses? What do you guys think? Again, based on the table here on the left, the probability of less given 18 to 34. All right. We got some changed answers there. Let's take a look, see which one is correct. All right. So we first have to look at the 18 to 34 category. How many of them exist in the 18 to 34 category? Because that's our given condition here. Well, we have 542 exist in the 18 to 34 category. How many of them are less likely within those 542 people? Well, 22 of them are less likely at the end of the day. So we are indeed going to get 22 over 542. That is correct. Okay, so 22 over 542 is correct. All right, so if we do that out here, 0.0406. Ah, see, Angie began to see now how we're coming up with these numbers. Notice notice what I'm always doing here. I'm always taking the condition first. I take the condition first, that's 18 to 34. I am working within a pool of 542 people. Well, how many of those are how many of those are less out of those 542? Well, only 22 of them. And that's how I actually come up with that particular probability. Hopefully that's starting to make a little bit more sense. Should we try one more? One more problem from this table? Would you like to try another example? Or would you like me to move on? You guys tell me. Another example, or should I move on? Yes, one more? Okay, that's fair. All right, let's do one more. Thanks, Dylan. Have a fun party. Okay. All right. Okay, now let's try this one here. Never too drunk. Okay. I appreciate that, Dylan. I appreciate that. Let's have a great time, my man. You gotta tell me some more stories. Let me tell you. You and I gotta talk. Let's see. I picked that one. Okay, no, I didn't. Okay, so let's pick. Let's pick more. Given 45, 54. All right, so the probability of more given 45 to 54. So what's the probability of more given 45 to 54? Apologies. Can you guys tell me what that answer is going to be? All right, so Chioma says 360 over 546. Okay, let's see what others have to say here. All right, Angie says the same thing, 360 over 546. Let's get a few more guesses in here. All right, Julie says the same thing there. All right, Hisa too. Anybody else? Anybody else? All right, Tori says that too. All right. Let's take a look here and see what answers that we get here for this. Okay, so we say how many people are between 45 and 54 in our chart, in our little table. Well, that indeed is 546. And how many of them are more likely to buy in those out of those 546? Well, that happens to be 360. That's absolutely correct. All right, 100% spot on, everybody. All right, now we're starting to get it. All right. All right, so we get 0.65, sorry. 6593. Yeah. Had to check that for a moment. Okay. And that's going to be our final answer for that. All right, good stuff. Good stuff. Are there any questions about that so far? Any questions? No. No. Okay. All right. Well, let's take a good look here at another problem. Okay. So if there are no questions, we'll move on. Okay. Now, before we get to this next question here, we'll talk about a couple of other things here. So this. Okay. So the next thing we're going to talk about here is talking about the general multiplication rule. Now, we actually went ahead and already used this in a little bit of a capacity, but I know maybe not directly. All right, so what's the general multiplication rule? Now, you could use the previous formula here. You can fudge around with a little bit of algebra. And you could say the probability of A and B, which we defined last time, again, as independent events, was the probability of A times the probability of B. Since these are not independent events necessarily, the probability of A and B is the probability of A times the probability of B given A. So this is just a different way to express how we went ahead and we could find the probability of A and B by just using the other two probabilities that we had found from before. And that can certainly happen. Okay, so no big deal here. It's actually pretty straightforward. However, most of the time, like I said here, what are we actually doing here in these particular given probability problems? Well, we're just kind of using logic to really see, okay, what's the number that we have to start with, and from that pool of numbers, how many people are we picking, based on the data that we're given here, whatever the case may be. Okay, so again, using those is not super hard. It just takes a little time to kind of get used to at the end of the day. Need to. All right. Okay, that's fine. All right. Just had to think about that for a moment. That's okay. All right, so let's look on the next part here. We're going to talk about this as well. So let's talk about this, and we'll do an example of each. All right, so number 6. What can we say about sampling with and without replacement? What can we say about sampling with and without replacement? So we could end up with a couple of scenarios where we end up with replacement, or we can end up with scenarios without replacement. So what is with replacement means? It means you replace that item back. So imagine, if you will, we had a deck of cards, okay, and I ask you, hey, can you pick a card out of a deck of cards? And I say, okay, pick a card, you pick a card, and then I ask you, okay, could you put it back in the deck? All right, so that's obviously replacement, and then we take a look at the odds of selecting a card maybe for that particular situation. All right, without replacement would be just the opposite. I ask you with the deck of cards, pick a card, any card. You choose the card, and then you take it and you basically hold it in your hand. Okay, you're not putting it back in the deck. You're going to use it for whatever purposes you're going to use it for. Seems fair. Okay, and of course here, just like we talked about before, we're going to be on the lookout for again the words such as at least or exactly. Again, both of these probabilities will be done a bit differently. So again, please be on the lookout for that as well. Again, wording, as we've talked about here already, and very extensively, does have a significant meaning. All right. So let's take a good look here on how replacement or non-replacement works. Look at a problem here. Here's my problem. All right. Let's look at number. So this one here can be a bit tricky. So we're going to go through this one a little slower. All right. But that'll be here with number 27, okay? Let's look at number 27, and let's see how it works, okay? So 27, playing music on a random setting. All right, so suppose that a digital music player has 13 tracks. After listening to all the songs, you decide that you like 5 of them, okay? With the random feature on your player, each of the 13 songs is played once in random order. Find the probability that among the first 2 songs played, okay, you like both of them, would this be unusual? You like neither of them? You like exactly one of them, and then we'll skip what D is. So D is kind of like not the point here. All right. Anyway, we'll look at the first one here. So let's break this down here a little carefully. All right. So we have digital music. This again, this let's say it's CD. It's got like 13 tracks on it. 5 of the songs, 5 of the tracks on the CD is something that you like. So let's say we have 5 we like out of the 13. We have 13 total. Now, what else does this mean here? If we like 5 songs, so I like 5 of the songs on this CD, all right, how many songs do I not like then? How many songs do I not like? 8, right? I don't like 8 of them, right? I mean, I like 5 of them. 5 of them are great. They're banging tunes, I could listen to them all day. All right, no problem. But 8 of them, I'm not a big fan. So okay, seems fair. So let's take a good look here at each one here. Now, a couple of important things regarding this. All right, one of the most important parts here in this problem is in this particular example, we're going to do things without replacement. Why? Well, because each song is played at least once in random order. Doesn't matter the order, but they have to be played once in random order before it turns over again. So this was the old, if you had an old CD player like way back in the day, they had a shuffle feature. And like the shuffle feature wasn't truly shuffle. It was actually a already pre-standard kind of shuffle. It wasn't really truly RNG. So every song had to be played once, and then it would shuffle again. So let's look at letter A here. All right, so let's say we like both songs. The probability that we like both songs. So 2 songs are played in a row, we like both. All right. So let's take a look at how we can determine the probability based on this. All right. So let's take the first song here. Let's say I like the first song. So the first one I like. I like it. It's good. It's a banging tune. What's the probability that the first song that I listen to is a song that I like? What's that probability? What do you think that probability is going to be? The first song that I listen to is a song that I like. What do you guys think? Okay, that's right. The answer indeed is 5 out of 13. That's correct. There's 5 songs I like out of the 13 tracks that are on this CD. Fair enough. All right, old school CD. It is what it is. All right. Okay, how about the second song? So now the first song's done. It was great. Second song comes around, and it too is a song that I like. What are the odds that the second song I play is a song that I like? 4 out of 12. Okay. That is correct. Very good. So understand that there's no replacement here, okay? You're not replacing the song. Once the song is played, you have to listen to every other song before you can come back again. All right? All right. So now that there's one less song in the pool, There's now, from 13 songs, there's now 12 songs in the pool. And then there's one less song that you like here, which is, again, that takes one out of the pool. So now there's 4 songs left that you like in the pool. All right, now we just go ahead and multiply these together. So multiply 5 over 13 times 4 over 12. And as a decimal here, what do we get? What is the decimal we get here? 5 over 13 times 4 over 12. Anybody got a decimal answer for me here? All right, guys, I'll wait for you guys. All right. 0.1282. All right, good. All right, very good. 0.1282 is correct. Very nice. All right, let's look at letter B. All right, letter B says, you like neither song. So let's go down the line here. Again, I'm just drawing it out. So again, the first song you dislike. Second song you dislike as well. So what are the odds that the first song you listen to you dislike? What are the odds that the first song that you listen to you dislike? All right. 8 out of 13? Yes. Okay. So far, so good. Sounds like bueno. All right. Now, the second song is also a song you dislike. What are the odds that the second song you listen to is another song you dislike? Seven over 12. Okay. Good. That is correct. All right, good. Because you take away one song from the pool, and again, you have one less song you dislike. So again, that gets taken away from the pool. All right, that's perfectly fine. Okay, and so what do we get here in this case? 8 over 13 times 7 over 12. What's that as a decimal? Point 3590. Okay. Take your word for that. About right. All right. Good beans. Okay. So far, so good. Okay. Let's look at this last one here, for this particular example anyway. Probably that you like exactly one of them. Okay. Now, you like exactly one of them here. Now, surprisingly enough, it doesn't matter which order that you go to because you'll actually find that they'll be the same probability. So, we're just gonna, you could say the first song you dislike and the second song you like, or the first song you like and the second song you dislike. So let's just kind of go with like the first song we like, and then the second song is a song we dislike. So let's say it's the first song we like here. What are the odds are going to be the first song that we like once again? I don't think that's going to be too hard, but once again, first song we listen to we like, what are our odds in that case? All right, easy peasy, just like we had in the first example. All right, agreed, 5 out of 13. Now, what are the odds that the second song we listen to after that, what are the odds that the second song we listen to is a song we dislike? One of those two is correct. It's either 8 out of 12 or 7 out of 12. I'll agree with the over 12 part here. All right, that is correct. The answer is 8 out of 12. Again, we picked a song we liked. We have 5 songs in the pool that we like, but there's still 8 songs in the pool we dislike when we haven't actually used one up. And we do have 12 songs left overall in the pool. So 8 out of 12 is correct. Okay, good. All right. All right, go ahead and multiply these two together, and what do we get here? What's our decimal equivalent here? Point. Oh, we got 2 different ones here. Let's take a look. 564 or 2551. All right, let's take a gander. We get 0.2564. 64 is correct, actually. 2564. Y'all don't listen to me. I'm just following the numbers, Angie. I'm listening to you. It's just the numbers are a bit off, and I have to question things. It's not to be insulting. It's just, you know. It's like one of those things. All right. All right. Wasn't trying to be mean, but alrighty. Okay. Any questions? Any questions about that? Any questions, guys, before we move on to the next example? Got a couple more. We got another example to do really quick, and then that'll be it. Nope. 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 All right. Okay. Let's do it. Okay. And I need to get that one. Okay. All right. We're going to do one more here. That'll be here from number 29. Okay. So let's take a 29. A bag of 30 tulip bulbs is purchased from a nursery containing 12 red tulips, 10 yellow tulips, and 8 purple tulips. Okay, now it says use a tree diagram, but we could just go ahead and actually you know, talk about with or without replacements. That's what we're going to do here. So what is the probability that 2 randomly selected tulip bulbs are both red? Now, I'm going to do this with replacement, okay? So for the purposes of this example, let's say we do it with replacement here. Without replacement is actually what we did in the last example. So we'll do it with replacement. So essentially, the way it would work here, once again, if we're doing it with replacement, it'd basically be like, okay, I pulled out a random tulip bulb. It happened to be red. I'm like, oh, it's red. I throw it back in the bucket of tulip bulbs. All right, and then I reach down again and pull another one out, which in this case turns out to be red once again. Okay, so let's talk about that here. So with replacement, let's say they're both red. What would be, let's take a look at the first and the second one. What's the probability that the first bulb here would be red? According to our problem here, what's the probability that the first bulb could be red? Probability that the first bulb is red. Well, 12 out of 266? 12 out of 30. Okay, there we go. Wait, where are we getting 266 from? Oh, no, this says page 260. Angie, this is page 266. I can understand what's going on here today. I know. Look, it's okay. It's okay, Angie. Angie, listen to me very carefully. It's okay. It's okay. We all brain fart from time to time. It's fine. I'm full of farts quite a bit. Okay. It happens. All right, it happens. I'm not blaming you. That's okay. Not blaming you at all. I have plenty of those. Let's see if I can adjust the zoom here for this. It makes it a... Let's see, is that a bit better? Hey, my eyes, Angie, are terrible. They're terrible. My eyes are so bad. Okay, 12 out of 30. Okay, let's pull out the second ball. That's better? Okay. Look, you guys tell me if it's too small, just tell me, guys. I told you this class is not about me, but I don't know if you guys can't read it unless you tell me, alright? If you tell me, hey, Professor Chibs, this is too small, I can't read it, then tell me and I'll make it bigger, okay? I don't have a problem with that. But I can't see what you can see. I can't see what you guys can see on your screen because I have a nice big, big ass monitor. So, you guys gotta just tell me in the future, guys. If you're having a tough time looking what I'm writing or whatever, just let me know, and then I'll be happy to change stuff. Okay, it's not a problem. All right. Okay, so the second bulb here is red. What's the probability? So I took the first bulb, I found it was red. I put it back in the bucket of bulbs. I then reached my hand in again, and I pulled out another red bulb. Okay, well what's the probability that the second bulb is red after I replace the first one? What's that probability there? So the second one is red with replacement here. $11 out of 30? $11 out of 29. 12 out of 30? 12 out of 30, he says with some conviction. Alright, let's go over the correct answer for this. The answer is indeed 12 out of 30. That is correct. So the difference here, and I'll let you know, for Tori there as well, is that in this case, remember, that the distinguishment that we're making in this case is we're doing it with replacement. So like I said, if we're taking that red bulb that we pulled out the first time, I'm throwing it back into the bucket. Now I went back into the bucket. There's still the same 30 bulbs in there that there were from before. Nothing changed. The layout didn't change. I'm not taking away one red. All right, I'm putting it back right where it was before. And so I still have the same scenario that I had before I even made the first pull. So that's why it's 12 out of 30 here in this instance. Now if I multiply these together here, 12 over 30 and 12 over 30, and with replacement. Right, so just kind of, yeah, so exactly, just visualize it as best as you can, and that's the way it works there. Whoa, that is... No! No! Things, no. Okay. So, so you probably got 0.16 here for that. Okay, good. All right, now that that makes a little bit more sense, let's try the second one. See how that works out. Again, with replacement. Let's say the probability of the first bulb is red and the second one is yellow. So first red, second yellow. All right, we'll put red. Red is the first pull, and then yellow is the second pull. All right, what's our probability if we pull a red? What's our probability that we pull a red? First pull. First pull probability is a red. What's that going to be again? $12 out of 30. Okay, that's correct. 12 out of 30. All right, that's fine. So far, so good. All right, so I have the red bulb in my hand. I see, okay, I mark it down. It's red. I plop it back into the bucket with all the other bulbs once again. All right, I reach in my hand here once again into the bucket. I pull out a yellow. Okay, so the second pull is a yellow. What is my probability that I pull a yellow after for the second pull here in this case? Again, this is with replacement here, so again, keep that in mind. All right, 10 out of 30. That's good. Okay, good. All right, so we're going to multiply both of these together. 12 out of 30 and 10 out of 30. All right, so let's do that here. All right, and if we go ahead and multiply those, get 0.13 repeating, just 0.1333. Questions so far? Let me throw one more question your way. This one here, not in the book, but throw this question here. I'm going to go with the scenario. Once again, I'm going to go with this scenario here without replacement. Same scenario for number 29 in terms of the bucket. So let's go without replacement here. Let's say I ask you, what's the probability of a purple and yellow on my pulls. Okay, so purple and yellow. So first one's purple, second one is yellow. All right, tell me the odds of pulling a purple from the bucket. What are the odds of pulling a purple from the bucket? First pull. 8 out of 30. Okay, sounds good, right? There's only 8 purple bulbs in the bucket. There's an 8 out of 30 chance. Now this time though, the difference is I take that purple bulb and I'm like, okay, it's purple. Mark that down. I put that purple bulb and I put it off to the side. So I'm not putting it back in the bucket. I'm putting it off to the side. I said I'm going to use it later. Okay, for whatever purposes. When we use it later, maybe I'll plant it. Okay. So then I go and I reach into the bucket a second time, and I'm like, okay, I see I have a yellow tulip bulb. Okay. So what are the odds that I pull a yellow tulip bulb the second go around? Ah, very good. Very good, everybody. They're noticing the differences here. All right, so the odds of pulling yellow is dependent on the purple because we took one out of the bucket. So indeed, that answer is correct. 10 out of 29. Very good, everyone. Very good. Okay. Now we just go ahead and multiply these two guys together. And bada bing, bada boom. We got ourselves a winner chicken dinner. All right. 0920. I get here. All right. Good stuff. Any questions about that example there? Or any questions about any of these examples, I should say. Questions? All good. Excelente. All right. Very good. Okay. Great job, everybody here today. Thank you very, very much. Let's go to the big face screen thingy thing. All right. Great job, everybody today. Good job here today. I want to thank everybody for coming on out here to the stream once again. Absolutely fantastic job from everybody. You really picked up on that probability stuff at the last at the end there. So I'm really happy to hear that progress. All right, we will be continuing on moving forward here with chapter 5. All right, if you haven't finished up the homework assignments or tests, remember that will be due tonight by 11:59 p.m. Okay, so be sure to finish and save before that time so you can get the full credit as much as possible. All right, if you're happy with your test grade, then there you go. That's all that matters. You're just fine. All right. Again, you guys know where to contact me. I'm on Discord or email. But in the meantime, everybody, concerning the test, if it's taken more than once, yes, that's how it always works, Chioma. Highest score is always the score that will be recorded. So even if you don't do as well the second time around compared to the first time, your highest score will be the only one that counts. So that will automatically be that's automatic for every single test in the class. Okay. Any other questions? Hopefully for test. Yeah, look, as fair as possible. Any tips? Well, if there's one tip I would tell you, one, don't wait until the last minute to do the test. And number two, do the practice test, because the practice test is the real test, as I mentioned here before. Never wait till the last minute, folks, which is today. I've given you 2 weeks since I announced this. So, like I said, whatever, I'm just going to give you fair warning here. Fair warning, like I mentioned here at the beginning of the semester. If you think what you did in high school is going to work from what it did before, the answer is it's not going to work. Because I've seen this time and time again. So, never wait until the last minute to do something. I was the same guy. I did procrastination station. And I was also the guy that almost failed out of college. So, yeah, don't be like me. Just don't do it. It won't help you in the end. So, and like I said, I'm not in the business of punishing people or doing that sort of thing. I'm not in that business. I just don't want you to fall for those same traps and things that, that happened to me. I don't want that to happen. So, I want you to do your best and put your best foot forward and pass this class and not have to worry about it ever again. That's what I would like you to do. Want to get through this together, so let's get through this together, yeah? So, there's any tips, that's like the first room of improvement is to break your own bad habits. If you're doing things at the last minute, break your own bad habit and get things done earlier. That would be my first thing I would tell you. Those things carry over, by the way. I'm just going to be honest with you. Any other questions? Any other questions? All right. So, as I mentioned here before, if you're taking the test tonight, good luck on your test. If you're doing some of the homework, make sure you finish that up by tonight. Otherwise, great job, everybody. Everyone, have yourself an absolutely fantastic and wonderful weekend. I hope all of you have a wonderfully fun and nice time. All right, everyone, take care of yourselves. And as always, everybody, as always, stay safe, stay healthy, but most importantly, stay sane. All right, have yourself a great weekend. All right, we will come back here, right here on Tuesday, same time, same place, everybody. We will continue doing Chapter 5. All right, take care, everybody, and we will see you then. Have a great one. Good luck. All right, we'll see you later, everybody. All right. Bye. Bye, everybody. Take care of yourselves.